Start
Recording
sharing
is
my
on.
screen. Okay. Is my screen visible?
Uh, yes, now it's visible. Yes.
Okay. So yeah. Hello everyone. Thank you for inviting me to this session, Masood. Firstly, and I would like to present this topic: the autonomy paradox. Why governing agents is what sets them free. And again, to give you all a brief introduction about myself, I'm a software engineer with over 7 years of industry experience in building production AI systems and backend systems. I'm specialized in agentic AI architectures and rack pipelines and multi-agent orchestrations. I've built strong foundation in Python.
Sorry, Manoj, may I just I think that we see
Mhm.
not the presentation mode. I guess because we see your uh,
Okay. Should I stop and start sharing once again?
yeah, maybe. I think.
Okay.
And
Let
I think
me.
if you put it in the full screen mode, probably that would be better. I guess.
Yeah, yeah, I have put it in the full screen mode. Yeah, now it is in the full screen mode again. Can you see it?
Actually, I don't know. I think I don't.
Click swap displays, maybe.
Yeah, yeah. Now, yes, now it's correct. Yeah, thank you. Yeah,
Okay.
yeah, please. Thank
Just a minute. Then I think I've shared the wrong display. Let me share the right one. 1 minute.
I think that was fine when you swapped. That was the fix.
Yeah. Now is it
Yeah,
better?
yeah.
Is it
Now,
with
now,
the?
now, yeah. Now it's good. Now it's good. Yes.
Yeah. So yeah, I was introducing myself a bit, and yeah, I've shipped AI systems that measured a good operational efforts across financial services, retail, and other industry domains. I'm also a proud inventor of two patents, and I'm also a mentor, and I do open source contribution actively. You can find me everywhere with my ID as Manoj Jagirdar. It can be on LinkedIn and any other uh, uh, forums as well. So this is the agenda for today, wherein I will be covering the state of AI agents in 2026, how the spectrum of the agent's autonomy look like. I will then show you all a demo of a SRE agent, how that agent works, and also I will show you all what are the possible failures at different layers. And we will see how to govern these agents at the different layers. And then again, we will see the demo with the governance on top of it. And then I will address why the governance is required, and we will conclude with the session. So let's get started. So, as you know, the state of AI agents currently, it has changed quite rapidly. Initially, when the Chat GPT and other AI system, Gen AI systems came in, it was in the 2022-2023 period, wherein we saw a lot of chatbots emerging. So, 23 to 24 was the span where we saw AI agents or the chatbots that could answer your questions based on the either the LLM's own knowledge or based on your knowledge document that you provided as a knowledge base to it. Then in 2025, we saw the rise of AI agents. So these agents were nothing but the chatbots with some additional capabilities. It got a capability to act, you can say, and it could invoke different tools, get different responses, and then it could give you more informative knowledge, and also it could help assist you with some decisions also. So that was the agent of that was the 2025 span. Now in 26, what we are seeing throughout the industry shift is uh, that is evolving.
Recording is on.
Do you okay? So do we trust fully on these autonomous agent systems, or do we still need humans and in the loop? And how do we gauge when to use these AI autonomous agent systems, and how governing them will let them free is what I will discuss in today's session. Again, as I mentioned, in 2026, there's a lot of rise of autonomous agents. It is no longer a research concept anymore. So the governance conversation has become unavoidable currently in 2026. So 80% of the Fortune 500 companies already use AI agents in production, and the adoption has consistently outpaced the security maturity. And we see that only 20% of the enterprise have matured AI governance process in place. So that is very less compared to the people using it. So most organizations developing the agents in 26 are at like level 100 or 200, and the maturity lies somewhere between the 250 to 300 range. And that's where like governed organizations are more in control when they have the governance in place. And also, we see that agents have outnumbered humans as identities in modern enterprise by about 30 times. So there are more agents than a human in a modern enterprise system. So we need a governance to it. I will explain how and what basically. So before that, let me set the stage by explaining the autonomy spectrum. So if I consider this spectrum over here, on the left hand side is where I will have more human control, and on the right hand side I will have less human control. And while on the opposite side, like in the left side, I will have less autonomy, and on the right side, I will have more autonomy. So these both are inversely proportional to each other. So what kind of systems are lie in between these? So to start with the left side, we have the assistants. So assistants are nothing but the AI that gives you suggestion, and there's a human, that every action is approved by him or her, and then it continues to give you the results. Then comes the co-pilots. So co-pilots are something which act within a task. A human approves the steps and it acts based on that. Then we have a supervised agents. So supervised agents are nothing but that execute workflows. Humans are present in at every checkpoint to take the any corrective actions, but these execute entire workflows by themselves, and they give the results. Then comes the autonomous agents. So these are the agents that can not only plan, they can act, self-correct, and also work in a dynamically changing environments. So with this spectrum, I can say that most of the production systems today lie in between over here, and they need to have governance. So if you talk about the governance, the left side, less governance is still fine, but on the right side, you need to have a lot more secure governance in place. So with this, let me show you an demo of an SRE agent. So this SRE agent is built with these LangChain framework and normal Quen2 model from running on my local machine. And what it does is it has three sub agents: a troubleshooter agent, a remediation agent, and a runbook agent. So when a user asks a question, it will be routed to the specific sub agent, and that sub agent will perform the task. So let's say if you're asking some troubleshooting related steps, it will go to the troubleshooter agent, and it can uh, log all the. It can go through the logs and find out the root cause of what is happening, and it will get all the access from. It will get all the information from your Kubernetes clusters. And we are using all the Kubernetes MCP server over here. And similarly, we have a remediation agent which can go and write to the cluster. And we have a runbook agent or the FAQ agent, which has a connection to a knowledge base, which can get information from the knowledge base and give you the results. So quickly, let me show you the agent over here in my uh, VS Code. So this agent basically is built through, again, with this modern era, this is built through Cloud Code. And I've used a spec driven development approach here, wherein I have a spec, software engineering spec with functional requirements and non-functional requirements, and the acceptance criteria for this. And with this, I can ask the Claude to build this agent for me, and I can evaluate in between as a software engineer and make sure that it is generating the right config that I want. And it has generated all this agent for me. Like there is a supervisor agent, there is a remediation agent, troubleshooter agent, and so on. So let me show you interacting with it, how it looks like. So before that, let me show you my Kubernetes cluster that I have, kubectl get all. I've created this demo app namespace, and this namespace here you can see has few pods which are purposely put in error state, crash loop back off state, and they have put in those. And I would like to see how this SRE agent helps find the troubleshoot this agent. So let me run this agent quickly. So I have created a CLI interface to invoke this agent and chat with it. So I will just say, let me paste over here. I will just say what's the health of the demo app namespace. So once I run this, it will go ahead and it will invoke the supervisor agent, which will then go ahead and invoke the troubleshooter agent. Troubleshooter agent will invoke all the required necessary MCP tools from the Kubernetes APIs, and it will try to get all the namespace, the whatever pods are there in this namespace, deployments are there in this namespace, and so on. So it will take couple of seconds since this is running completely local on my Mac. There's no LLM that has been inferenced right now. It might take some amount of time, but yes, let me wait for couple of seconds to show you all the result, how it comes up. Then I will talk about what is the issue with this result. Again, I have built this with a proper software engineering spec and functional and non-functional requirements. I do have test cases, and I do have all the agents and tools working fine. But where is the, like, on what different layers does a problem occur? I will talk about that. So let me give it couple more seconds. By the time it comes and gives me the results, yeah, should be here anytime soon. So shouldn't take much longer. It should give me the remediation steps, the troubleshooted information summary, and the remediation steps, of course. So I'm waiting for this. Okay. I will wait for a couple more seconds. If not, I will go back to the, yeah, I got the results. Okay. So here you can see it has given me the results, and you can see it is saying the inventory worker payment tab are in the experiencing issues. There's a crash loop back off, and the payments API is in the error state, and it is giving me all the kubectl logs as well, and it is also suggesting the different remediation steps over here. And also it will say, okay, I'll call the search knowledge base agent to get the query related to crash loop backoff and error state pods. Okay, this is the result that I got. So let me show you like what uh, layers of the failures we can see over here. So there are four layers in this autonomous agent stack. So there's an infrastructure layer, there's a model layer, there's an agent layer, and there's an orchestration layer. So let's see at each layer what can go wrong and how we can govern them. So let's start with the infrastructure layer. So at infrastructure layer, failures that you can see are basically the unbound blast radius that you see. So according to this report that I have, there's like 68% of organizations that cannot reliably distinguish whether an AI agent has performed the activity or human has performed the activity. Only 5.7 have the full visibility into the service accounts that they have. Now, only 20% of organizations also have formal process of offboarding and revoking APIs and non-human identities, basically with recommended within recommended time frame. So in my SRE agent again, if I set it to start the remediation steps, it would have gone and maybe it could have also deleted the pod, or it could have deleted and restarted it again. Such things will affect my SLAs. So to give you a case study, so in February 2026, AWS disclosed a 13-hour production interruption. So this production interruption was mainly because an internal AI coding tool was allowed to execute the infrastructure changes, and it chose to delete and recreate an environment. So that brought up down the SLAs, and it gave a 13 hours production interruption also. So why does it matter at this layer to have governance? Agents are privileged non-human entities, and it must be managed accordingly. So you cannot just treat them as some other entities and leave it off. So you need to have a uh, proper way to manage them. Again, standing credentials means standing blast radius. So to contain that, we need to give the access in a scoped way. And if the agent has no owner or no audit trail, there is no way to revoke the path. So if there's all needs to be an audit trail, I will show that in the governed agent that I am having. So with that audit trail, you will be able to recreate the entire disaster path also. Now comes the failure at model layer. So this is where hallucination becomes a liability. So in the SRE context, hallucination follows a concrete error propagation chain. So the if the troubleshooter itself gave me wrong steps or wrong troubleshooting response, the remediation agent will do wrong steps, and it will try to remediate something which is not there itself. So it will go on propagating further. Again, the context limit of every model also amplifies this, and with roughly 20% performance degradation on mid context information, it becomes even more catastrophic. So again, another interesting case study where we saw a failure at model layer. So in February 2024, Air Canada's support chatbot invented a bereavement refund policy that did not exist at all. So a passenger relied on it, and he was denied with that. So he went to the court, and in the tribunal forced the airline to honor this fabricated policy. So you can see how it can affect the enterprise if there's a failure at model layer. So again, why governance matters at this layer? Fabricated figures, stale data, and context drift are model level failures, and that needs to be contained. Uh, Again, confident unsighted output was treated as a company policy in this case. So if the uh, agent gives you a confident wrong answer, then it becomes a problem. Again, if the agent has no grounding data, no confidence threshold, and no source citation, the response cannot be trusted blindly. Next comes the agent layer. So how do we see a failure at agent layer? So this is called as excessive agency. So the real risk of this AI agent isn't just the model getting answers wrong. It's that agents can act with more access than it shouldn't while no one is watching. So that's what happens like in the SRE agent now. If it goes and if it is put on complete autonomous mode and it goes and tries to identify a wrong uh, troubleshooting step, and then it goes and try to remediate it, then it will be a problem altogether. And that is the real risk at this agent layer. A chatbot that hallucinates wasn't wastes a reply basically. So we saw that if the model hallucinated, it just wasted a reply. But an agent wired to CRM, a payment system, or an inbox can do the real damage at machine speed. So imagine in a retail scenario where you ask the agent to give you a refund, and it hallucinated and it started processing refunds. So that will be a catastrophe. So again, another interesting case study over here. In July 2025, there was an explicit code freeze. Code freeze means make no changes to the code anymore in a SaaS company. And the agent went and deleted the production database even after explicitly mentioning that there's a code change. And it executed like 1,206 records, and 1,960 company records all were deleted. Then to cover it up, it generated 4,000 fake records and fabricated logs to cover this. So you can see the problem that it caused. So again, at this time, the OWASP formalized this term called as excessive agency, and it is named as LLM 06 2020 colon 2025. So the durable mitigation is default denial tool access, short-lived scope credentials, and human in the loop to avoid this. Again, why it matters at this layer? Agents with wrong access can cause catastrophe. Instructions to a model aren't the controls for your system. Like you cannot just prompt the agent to do something. You need to have permissions and controls to your system. Now we'll see why how there can be a failure at orchestration layer. So at orchestration layer, there can be a cascading effect without any circuit breaker. So in the production SRE agent that we saw, on an average, tool 3 to 5% of the time, you can see failure on a tool call. So let's say it called the Kubernetes list pods or let's say list secret tool, and it did not go through. So you can there are from 3 to 15% of the times you can see the failure. So at 3%, let's say we start with the 3 to 15%, right? At 3%, the incident requiring, let's say, about 30 tools carries out a roughly 60% chance of at least one tool failure. And at 15%, this gets increased to 99%. So that's where we saw another interesting use case, use study, where in January 2026, an airline's autonomous booking agent, it systematically rebooked about 1,200 plus passengers onto a wrong flight during a weather disruption. So after analyzing 73 production agents incident, it was found that the failure stack was across the layers, and 61% of multi-layered incidents and retrieval failures upstream caused the tool call downstream to go wrong. So orchestration is very important. So we see that um, one bad decision can propagate throughout the whole workflow. Right tool, wrong context, and the orchestration not validating the state will lead to catastrophe again. So even if you're having the right tool, but it is called with the wrong context, it will cause catastrophe. Without a circuit breaker, it's like the agent doesn't fail; it fails repeatedly at scale. So now we know the four layers in which we can govern the agents now. So these are the four layers: orchestration layer, agent layer, model layer, infrastructure layer. And we saw how catastrophe can be formed at each of these layers. Now, how do we govern each of these layers? So let's start with infrastructure layer again. So we will govern as a whom in this particular infrastructure layer. So we set the agents with proper identity and ownership. Every agent has a name, an ownership, a defined purpose, and measurable access scope. And it should have short-lived credentials like just-in-time scope tokens, no standing keys, rotation, and revocation is built into this particular agent. Isolation and sandboxing is another critical aspect at infrastructure layer, so that it can contain the blast radius. So you're scoping like what you can do it in particular sandboxes, and production access is zoned and environmentally scoped to that. Finally, immutable audit trails. So distinguishing agents from human activities and logging every action of to the real identity is very important. Then comes the governing at the model layer. So we govern what the model says basically. So we can ground it with the RAG, answer only from verified sources, retrieval over recall for facts and figures, citation or abstraction. So always the LLM should cite the source in the format like source and link from where it has brought this information, so that the user is more trusting this system and is more confident. It should say like I don't know in case of no confidence rather than just giving some hallucinated answers. Groundingness threshold for high risk use cases demand less than 5% hallucination with mandatory validation checks as well. So if you're building something in healthcare and it is absolutely not acceptable to have anything hallucination, it is mandatory to have hallucinations less than 5% with validations, because nothing can go wrong in that particular industry. Then continuous evaluations are the golden question sets that we call, and the drift monitoring before and after deployment should be there at this particular layer. Then at the agent layer, um, the agent should have least privileged tools. By default, deny access to all tools. Only grant only what the task is needed. Action boundaries, read versus write versus execute, are all separated. You boundary the proper execution, and again, you gate explicitly the irreversible actions that your system might have. Assume injection succeeds. So it is always important to assume that the prompt injection has happened. Your system has uh, failed to stop this prompt injection, and then build a system in such a way that the compromised agent must not be able to do any damage or harm to your system. Behavioral guardrails is also very important, wherein input output validation, topic restrictions, and PII policies should be filtered at runtime. I will show that in this particular SRE agent as well. Um, then comes the orchestration layer, where you will govern when and how part of it. So human in the loop gates, high impact steps such as policy change, runbook execution, PII must require human in the loop at all times. Circuit breakers are required, like you can have a rate limiter, you can have a halt, the execution limits, rollback paths, and stop cascading at the earlier stages. Then decision trace logging. So full reasoning trace cuts the incident resolution by more than 4 times. So if you have an entire decision traced out, I will show that how it can be done. Um, and also state validation. Verify content between the steps, since right tool with wrong context is still failure, right? As we saw. So before and after the tool is called, you need to identify if the state, whatever the LLM has reasoned and whatever it has tried to invoke the tool, is it the right reasoning, or it has reasoned wrong and trying to invoke the right tool with a wrong context. So the SRE agent that we saw earlier with governance looks something like this, wherein there's a governance layer at top. When user asks something, it will go through input sanitization. It will identify the execution budgets, human in the loop approval gates, and output validations, and then it will go to the supervisor agent. This time, the supervisor routes to any of these agents. These agents have a scoped read-only or short-lived credentials and only specific accesses. And each, like let's say the remediation agent, when it needs to access your Kubernetes cluster to write something, a human in the loop is triggered, and human needs to approve that before it can do anything. And everything is covered under the audit trails and observability, so that even if something goes wrong, and I can reconstruct the entire thread that was executed even after 3 months. I can try to reconstruct that. So let me quickly show you all this agent with the governance. So let me come out of this. I'll go to the branch, git checkout governance agent name. So here I will show you what additional things I have added. So I have added in the spec, you can see here, there is, after all the functional requirements and the non-functional requirements, there is also a governance section. And this governance section talks about all the circuit breaker, like every tool invocation, interrupt system. And there are a few logic that is required for the uh, governance part of it. So let me show you how that looks like in execution. So again, the agents remain same, a little bit of changes in the way they are built and they are executed. So let me quickly pull up this as well, and I will again ask the same question: what's the health of the demo app namespace? And by the time this thinking completes, I will also like to show you this logs. So you see now this time it is generating this logs over here, that the audit trail basically, and with proper timestamp and the type what has happened, a thread ID and everything. So it started, session started, the agent started executing, it went to the supervisor, supervisor handed it to the troubleshooter with this context, and the names, the tool pod list namespace was invoked with this particular args, and it gave this particular output. So everything is now in your audit trail. So if something goes wrong with this particular execution or this thread, you have the audit trail for it. Next time you can reproduce this entire thread with this particular audit trail, and you can see where it went wrong. Did it go wrong in the supervisor step? Did it go wrong in the handoff step? Did it go wrong in the tool execution step? Where did it go wrong? So everything can be identified properly. So here, yeah, I think it brought, you can see supervisor was handed off again to the troubleshooter, and it is giving these symptoms and other things. One thing here you would see is, since we have grounded it with the knowledge base this time. So there is run books here. So there's a crash loop back of run book. There's image pull back of run book. OM killed run book. So we have created few run books, and we'll see this agent will try to also give you a grounded result saying, okay, you need to refer this run book in case of crash loop back off. So that grounding is also added here. So all this are taken care in this governance base, adding governance to this agent, and now you will have a much better, much auditable agent over here. So by the time it executes, let me come back to the presentation, and I'll show you the results once it's back in the interest of time. Um, Okay, so I gave you an example of an SRE agent. What about other industries, like let's say financial services? Let's say you're building an financial services research and analysis agent, or some agent that is going to get the stock tickers, financial market analysis, the S&P 500 outlook reports, and it is going to give you a summary out of it. And that works fine. Now you or the user asks something about financial advice, like should I buy this Tesla stock, should I sell it, should I hold it? Such questions, if the agent answers and the user goes into a loss tomorrow, the blame will be on the agent, and the reputation of the company will go down. So in that case, at the higher layer here, the governance layer here, we need to ensure that the questions that are related to the financial advisory needs to be constrained, and it should say no, I cannot execute it, that is out of my scope, and it should come back to the user. And also the financial disclaimer is very essential. So after every execution of every agent, or the response, the disclaimer should be added in the case of financial research, like okay, this is just for your information purpose, do not make any financial decisions based on the information that you saw. That is in the financial services industry. Let's say in retail and e-commerce industry, uh, again I mentioned this. So there's, let's say, a policy where you have defined the refund, like above a certain threshold, like above $100 you cannot refund, only below $100 you can refund. And the human comes in and he tries to trick the system, or he tries to bypass the policy, and he gets the refund. So without human in the loop, the refund API getting executed, and the human taking away the refund is again a problem. And without a proper audit trail, you cannot even understand like how and where, why this refund was issued. Or let's say today the policy says $100, under $100 we can refund, and tomorrow, the after 6 months, the policy has changed to under $50. And between today and 6 months you had some transactions where the person was refunded. Now, with according to the new policy, you are not supposed to refund, but according to the old policy, you have refunded them. Now, how do you check all this? This is all help. I mean, you can all trace it back with the uh, audit trail again. So you can bring up everything from where, what was the policy that time, how much was it allowed, and based on that, you can reconstruct that. And in terms of human resources like HR use cases, you have policy documents and everything within the system, and you want to ask something about the policy to you. Again, um, always ground it with the citation, like this is brought from this policy document, and this is the source link for it, and this is where it lies. That will help in identifying and causing less, it will be more governed system, and which will cause less disruption for your organizations. Okay, so here you can see it has come up with the results now, and it has identified the root cause, and it has also recommended this run book here. So now that we have grounded this with the run book, it has come up with the steps. And also you can see this, it is saying the proposed remediation steps. Before executing, it is asking for a human in the loop approval, and it will not go ahead and do it on its own. So all these make the system more robust. Now, coming to the conclusion part of it. So why do we have to use this governance now? Again, voluntary governance is a closed window for now. The regulatory has become more strict. We have the EU Act, which will be enforcing the High Risk Act from August 2026. The penalties will go up by about 7% of the global turnover. And there are more emerging baseline policies that are being enforced. Again, financial regulatories are treating this incorrect AI output as a compliance violation and not a quality bug. Earlier, we could say that this is some quality bug within the AI agent or AI chatbot, but now it is considered as a compliance violation. So, where do we stand? The organizations need to assess this very carefully and understand where do we stand. Uh, Most organizations, as I mentioned, like they sit between 100 to 200 level of maturity, wherein they have agents in production, informal governance is in place, but at least level 300 is required, where we have enforced environment zoned governance. That is the threshold required for the responsible production, productionizing the agents. So a quick question to ask: could you pass an agent auditability audit today? So let's say if an agent audit needs to be done today, and you are asked like a specific thread or a specific chat that happened 6 months back, can you reproduce that? What happened in that particular trace? If you're able to do it, congratulations, you are already on the 300 level. Uh, okay, so to conclude this session, risk grows with authority, not intelligence. So govern what the agent can touch. Govern in layers. We saw model layer, agent layer, orchestration layer, infrastructure layer. Each catch what the last layer led through, and then assume that prompt injection always succeeds, so that you can design an agentic system that are harmless when they are compromised. Decision tracing are non-negotiable at this point. You can't fix what you cannot reconstruct, so you need to be able to reconstruct whatever thread you need to see today. Governance is the enabler. Govern teamship more autonomously, faster, with confidence. Yeah, that was all about the session today. And thank you so much for the time.
Thank you very much, Manoj. It was very interesting topic. Uh, so actually, I ask if there is any question. It was very interesting talk. If there is any question to Manoj, otherwise I actually have some.
Yeah.
I see that in the basically today. I don't know. It was my understanding. Basically, governing today, we cover the aspects of the fault management, isn't it? So it's like when
Mhm.
we say like governing the AI agent. So which aspect basically we are going to cover? And today we focus on more fault management aspect. Is it like correct?
Fault management, as in, like,
I mean,
can you
like,
elaborate about this?
because I see that, for example, for each layer, so we had it,
Mhm.
and then we say, okay, if we have fault in each layer, and we try to see how we can
Yes.
basically govern the faults that coming from each layer. But when
Yes.
we say the governing, I mean, in general for the AI agents, so does
Mhm.
it cover more tasks, or is more like the concept? It means like handling the faults of each layer.
It covers the entire spectrum of the agent. So again, governance is not just like adding a PII filter on before your agent can reply back, or adding a disclaimer at the end. So that itself is not governance. It is the entire spectrum where you can identify where your system might fail and how you can govern those and basically build a better system.
Yeah, yeah, that is the. And I think that we have also some question. Dimitri, do you have any? Please.
Questions and remarks, and it's appropriate. Thanks, Manoj. Very, very, very interesting. Several concepts I recognize from my own enterprise background and also my agentic engineering framework I've been building exactly because of that. Just firing off some not structural thoughts that pop up and try to take that stream of consciousness. One thing you say, you gave the example of the database
Mhm.
edit, and I fully recognize what you
Yes.
say about having the traceability. I try
Yes.
to do that by and it touches a number of things. There's one question. One, if you have a good control framework, that change management on your database is not something that lies on the level of your agent, right? That's just a
Right.
root cause analysis after the fact. If something gets mutated, the control is on the database level already. But
Right.
to find out how that comes. The other one I saw in one of the two slides back is what I try to do is to have everything that's done with agents also, but also human interaction conversation, try to capture that so you can have traceability from the beginning
Exactly.
to the end, from the design decisions also, why did we do things and how do we do that. um, and you said in your decision, you said something about the decision that you need to risk it, but it's also capturing that decision at the moment it's being taken and being able to control that is the essence of make a decision. Do it autonomy of the agent, or is it sovereignty of the human in spot? And there's challenge on, you want to have a model that you don't have to click every decision, so you want to learn from that, what's on based on which risk can I make the decision. And like that, the stream of consciousness in practice, have you already seen what kind of mechanisms have you built to try to build that telemetry, to build those tooling to support that decision making and that control?
Yeah, so mainly primarily you can use any of the open source ones as well. Like you have the Langfuse that is all readily available. So you can directly use Langfuse to your agents and it will give you the entire traceability or the telemetry for that. There's also Arise that is there, Arise Phoenix. And there are a lot of available tools out there that can help you trace this entire system for you.
Yeah. Okay, thanks. And you're using it also to manage your infrastructure at the moment?
Um, Infrastructure, sorry, I didn't get that question.
Like your Kubernetes
Mhm.
cluster, for
Mhm.
instance. So, okay, that's just
Mhm.
interesting. It's because you have so much domain expertise in agents, that seems to be also, apart from coding, a very excellent use case to use it. And the challenge there is, how do you go from stochastic to deterministic? Somewhere you need to have that agent in, because that's the predictive
Yes,
maintenance you want to have, and also the reactive maintenance. But somewhere you want to manage that risk, so you need to take it from this really stochastic principle to the deterministic way of working.
right. So when the rule books are basically the workflows that we define for these agents. So earlier, as an SRE, what we used to do when we get an incident or when we get an incident, basically we used to go ahead and go to the Kubernetes cluster, go to the events, go to the logs, then try to identify what caused this particular incident and trace it back till there. And we also had certain run books. So if you get a 502 a PG monster error or any of the other issues, there's a rule book for that. And as a human, as an SRE, I went ahead and I fixed those. I did those execution steps from that run book, and I brought back the pod or I brought back the instance. Now that run book itself is like a workflow to my agent. So the agent can, with the proper scoping permissions, it can go ahead and find the pod logs, Kubernetes events, and it can also uh, run these workflows or the run books to remediate those as well. So that is where like we are shifting towards the autonomy spectrum.
Acha, thank you. So I saw a number of remarks or suggestions coming up in the chat.
Mhm.
Yeah, sorry. Yes. And So thank you very much. And do we have actually Torah? I see that mentioned about the references. So Manish, do you have some? I
Um,
mean, because then it would be very. I mean, like about especially about the tools that you mentioned. So that would be very interesting for people who can basically use these tools.
yes,
Um, yeah, I mean that would
let
maybe
me
if
put that in chat.
yeah, or if you can provide maybe some of the for the tools that could be very
Yeah,
interesting. It is
maybe if you could add a bibliography page
yeah,
with references would be very nice.
yes.
Yeah,
Thank you.
I'm just putting a few.
If you manage, can please, I mean that
Mhm.
you provide me some references. I can post it on the LinkedIn, and then people can actually have it and use it there in the link. And then we have it there by your name.
So I've also
Yeah,
plugged in something I've been working on, and to be honestly, I don't know if it's uh, just some another one that's making its own tool, but it's I started trying to get that control, and started creating my engineering framework. And here a lot of the concepts you've been talking about, my knowledge, feel back in that. Like blast radius got a
mm,
component fabric that maps our components. And when I create a prompt, I query that context to see what has upstream and downstream effect. Got
right, right.
context fabric, that's the whole traceability, that you go back and find what's been done before if you have a change or a new development.
So sorry, what was the question here at the last? I sorry, I missed it.
No, it was not a question. It's just I
Confirmation.
Oh,
shared a link, and a little bit
yeah.
like another one putting its own framework in there, but it just
Okay.
it resonates. I'm just really curious if it's um, um,
Yeah,
can
I
be of
will go
any.
through this. Yeah, this looks interesting. Yeah, I will go through this.
Yeah, and actually, Manoj, if you please, I mean, like,
Hmm.
yeah, after you provide me some kind of post on LinkedIn about the tools and also this, yeah, the layers, that would be very interesting. So I can have basically on the LinkedIn
All right.
by your name. That would be very nice.
Sure,
Uh,
sure. I will share
I
it across to you.
I have a question. So
Yeah, please.
let's say that
Hmm.
you want to have cluster management system to audit, go through the audit logs. How would you do? You have a good way of securing it? I mean, I was thinking maybe rsyslog, forwarding it to a Splunk server or something like that, and then using the logs, the Splunk logs to do the actual AI, um, yeah, parsing all the logs to find memory errors on what node, what DIM, what what is actually wrong, or maybe a application that has been killed, going through the log and which node it is from and so on. How would you like secure it and make sure that it's not going in and actually starting controlling the cluster? Do you,
Yeah, that's a very valid question, and that is where like all your RBACs and scope permissions come into picture. So, firstly, identifying the log, like reading the log and identifying the patterns itself is a initial task for a human, I would believe. So, what in your log is important for you, and what is a junk for you in the log. So, identifying that itself is a task which you need to do it predominantly. And once you start identifying those, then you can automate that. Like, okay, if I find something like this falls under more of a AI ops, I would call it. And once you have that pattern and you know what needs to be fixed, then you can build agents and scope the permissions to like never execute anything without a human approval. Always have a human in the loop before you can execute any remediation steps. It can at the most give you the remediation steps, but do not let it autonomously execute those without your approval.
It
Yeah,
sounded like the question was actually two part. One part is how do you collect and store those, and the other one is how do you secure it so that the information that cannot be made accessible by others, but also possibly, I don't know, but inferring that the agent doesn't use that to do stupid things you don't want them to do.
yeah, exactly. I would like the agent to drain, let's say, drain a node, slurm drain it, and say that okay, it's drained because you have excessive memory errors on this
Y-
node.
just thought you can do your telemetry on your node and then push that in a vector database and then start getting patterns from that and use those patterns to, depending on your risk assessment, right, to auto heal or just to service it to your operator for action, just as you would do any event.
Yeah, I mean, I do it kind of manually now. I mean, it's Gemini. Gemini is very good at machine errors. Obviously, I think Google is using it internally, and so the actual the troubleshooting for most of the things I'm looking for is already in
Yeah.
their model. So, but I'm very curious to see if anybody actually have done this. I mean, you have obviously systems like embedded support partner from Gray and SGI that did this back in the day, but it wasn't LLM based. It wasn't agentic based. It was just parsing logs and recommending. But I was wondering if anybody have seen like this type of system that is used, yeah, agentic AI. I mean, you have AI ops from Splunk and
But the
Fortinet.
principle, as you do your collection and your propagating and your condensing, as you do with Splunk, I guess remains the same. I haven't seen Splunk for a while, but I guess the next step then comes is the inference, is the analysis on it and the detection where you can use your LLM in. You take the data set and say, go look for patterns that are interesting. Does that make sense?
Yeah, right.
Yeah.
Yeah, I
Or
think
I'm
it would be a very good research
Yeah. Yes. Yes.
topic.
Yeah. Yeah. Exactly. I think it makes the like the administrative stuff is much more like easier. Yes. Okay, great. So thank you very much. I don't know, is there
Yeah.
any other question? No. Okay. So thank you very much. So maybe I can conclude the session. Actually, it was the first session that I see that we had some fake user. So I need to edit some videos.
Okay.
Yeah, so it's good actually. We learn more, so we see how we can handle the session. So next
Yeah.
session, yeah, that was good. Yeah.
Again, that's where you add a guardrail to this session as well.
Yeah, yeah. So then I need to so basically edit the videos. But
Yeah.
yeah, he's good. So thank you very much, Manatan. Thank you everyone for joining the session.
Thank you,
So
everyone.
thank you. So have a
Bye.
good day. Bye bye.
Yeah. You too. Bye.
Bye bye.